Thank you very much. I appreciate you all attending, and I want to especially thank our visitors from JCI who have come a very long way to participate in these sessions and in this series of 4 sessions. It's been wonderful working with the JCI leadership and the JCI members who are very interested in collaboration between ACI and JCI, and I've been a longtime supporter of that collaboration, so thank you very much. As was mentioned, I'm currently chair of the ACI 318 Building Code, and I'd like to spend a little time today talking about how sustainability might figure into the structural building code. And of course, the first question many people have is, why should we be talking about sustainability in an engineering design code? And perhaps I can explain that as we go along. Let's see, I believe, there we go. So here's a brief outline of what I'm going to talk about. Very briefly, the environmental impacts of concrete construction. I think we've all heard a lot about that, so I'm not going to spend much time on that. I'll talk about how ACI as an institute is approaching and dealing with sustainability as a very important topic today in the world, and what ACI's role is in that. I'll talk about what can a structural engineer do about sustainability specifically. I'll describe some of the new sustainability provisions that appeared in ACI 318-19 and some possible, we're working on them now, provisions that may appear in ACI 318-25. All right. So first of all, I think probably we have all seen a graph like this. I remember seeing a version of this back as an undergraduate, and the curve was a little shorter back then, but it has the same trend, and we have a very precipitous increase in carbon dioxide in the atmosphere, and there's a lot of causes for that, but one of them is the production of cement. There's no getting around that. Some estimates vary, but the one I think is most often cited is that around 8% of global CO2 emissions come from the production of cement. Now, some of that is the actual chemical process of producing cement gives off CO2. There's also the production related to the energy required to produce cement and the CO2 that is given off by producing that energy. In any case, it's a significant portion of atmospheric CO2 each year. So what is ACI doing about this? Well, there are many people and many groups within ACI who are very concerned, and I want to just describe for your benefit some of the things that ACI is doing with regard to sustainability. I have a list here, and I'll briefly touch on each of these points. First of all, we have a lot of publications. ACI publishes a lot of information. In fact, that's ACI's mission is to provide the tools and information so that people can, engineers, administrators, whoever needs that information can get accurate and up-to-date information to both design and produce concrete structures. And there are many publications, in fact, probably more than this, related to sustainability. We have at least 40 standards and guides that touch on sustainability. We have many journal articles. In fact, this figure is about 2 years old. I'm guessing we have another 30 or 40 in that category. And also we have practice-oriented papers and articles. These are practical real-world engineering and materials discussions that help people understand how to deal with sustainability in the here and now. We also do a lot of education. We try to distribute information to give people the best tools that they can to address sustainability issues. We have a lot of online learning available, both live and recorded webinars and presentations. We co-sponsor events that are related to sustainability. We have technical sessions like this one at ACI conventions. And we also have a program called ACI Ambassador Speakers, where ACI sponsors speakers to participate in international activities, particularly conferences, to help provide some guidance on the information that ACI has available. We also have a lot of committee activity related to sustainability, and one of the major committees within ACI technical committee structure is ACI Committee 130. It's a very large committee, over 100 members. There were, as of about a year ago, about 8 subcommittees working on specific topics. And I would particularly invite you to have a look at their report titled "The Report on the Role of Materials in Sustainability in Sustainable Concrete Construction," which is a very good overview of the topic. And of course, this information is being constantly updated. It's a rapidly evolving topic. This is from 2019, this report, but it is still a valid and very informative report that I invite you to take a look at. We also have a new ACI Technical Committee 321 on durability. Now, durability is an aspect of sustainability because obviously a more durable structure is one that lasts longer and requires ultimately less reconstruction to replace a structure once its life has ended. So if it has a long life, that's a more sustainable sort of use of concrete. There are 15 voting members. They are working on organizing this initiative, and I think they're well on their way to producing a concrete durability code. Perhaps most importantly, in 2022, ACI launched a new center of excellence called the NEU Center. It's a center aimed at moving towards a goal of carbon neutral concrete. And given the statistic I gave earlier about the high percentage of CO2 that's produced by cement production, you might think that's a very ambitious goal. In fact, it is, maybe surprisingly, it is an achievable goal. So NEU is working on that. It's very well funded. The goal of NEU is to make sure that anyone has access to technologies and the knowledge needed to create carbon neutral concrete and to use it. There are a lot of participants in the NEU Center, including donors and technical people. Here are some of the contributors. You'll see in there Baker Concrete Construction, Meta is involved. Cement producers such as Ash Grove and so on. And so it's a very collaborative, broadly based initiative, and I am very happy to see that ACI has formed this center of excellence. Okay, and finally we have ACI certification programs, which you may be aware of. These are programs that provide official certification of technicians, and in some cases engineers, to perform specific functions in the concrete manufacturing, production, transport, and placement of concrete. And we see here 2 new programs have been added recently: a concrete construction sustainability and resilience assessor. So there needs to be someone watching and recording the sustainable activities and materials that go into a project. And so ACI has an inspection certification to provide training and certification of those individuals. Also, there's a new initiative which has just been put into place and is just becoming active. It's an ACI 318 Design Professional certification, which is not exclusively focused on sustainability, but it does include some aspects of sustainability in this program. I invite you to go to the ACI website if you'd like to learn anything more about any of these certification programs. As you see here, there are 31 currently, and more are under development. Okay, now to get down to the heart of why we're here. Many of us are structural engineers in this audience. What can we as structural engineers do to promote sustainable uses of concrete? And so I'd like to talk about those topics briefly. I'm speaking now for myself when I say we are structural engineers. You may not all be, but I imagine many of you are. What can we do, we're engineers, to reduce the environmental impacts of concrete construction through innovations in specifically the structural design process? At first, it may not seem that structural engineering should have much, if anything, to do with sustainability, but in fact there are, I have this list of 5 simple things that we can do in our everyday practice to promote sustainable uses of concrete. We can, perhaps number 1 is to specify, to allow and review and specify concrete mixtures that incorporate alternative cementitious materials which have a lower carbon impact. These are evolving rapidly. Every convention I come to, I encounter a new alternative cementitious material. Those are, it's a very active area of development and research, and a lot of attention and money is going into those materials, and I think it's great. We just have to see how the marketplace shakes out, how the economics shake out, and where we end up in a few years. But we're headed towards lower carbon cementitious materials, definitely. We can use recycled aggregates in some applications, and I'll explain what the code says about that. The 318 code says about that in a minute. One very simple thing to do is to allow a longer period of time to reach the specified concrete strength F'(C). Traditionally, it has been since it was chiseled in stone sometime a few thousand years ago that 28 days is the period to for accepting concrete strength. There's no reason it can't be 30, 32, 56 days. And if that's acceptable on your project, and it would reduce the carbon impact of your project, there's no reason you can't do that. So it takes coordination with the contractor, obviously, but that is an option. As always, we should be seeking maximum economy by reducing the amount of material in the structure. But if we renew our focus on minimizing concrete volume, for example, using repetitive members that are identical, when in fact maybe we could use two different sizes of members, creates a little more work in formwork, but perhaps could save a lot of concrete as a way to reduce carbon impact. And finally, we can promote sustainability provisions in structural codes and standards, which is exactly what I'm doing here today, and what we're doing in ACI 318. And I'll move on to that now. These slides just highlight those points. So what about sustainability and the ACI 318 building code? Well, until the 2014 edition, when sustainability and concrete contribution to atmospheric carbon really began to become important, there were no sustainability provisions in the ACI building code. We introduced a very minimal section in 2014, 31814, which says you can include considerations of sustainability in the structural design, period. That seems like a very passive, unimpactful statement, but it was a start. We started mentioning sustainability in the code. And as an added part of that provision, we said if you consider sustainability, it must not interfere with or take precedence over strength, serviceability, and durability. Okay, fair enough. I think that was generally understood already, but we said it right there in 2014. Now, if we move ahead to the 2019 edition of the code, in addition to that kind of neutral statement about sustainability, we also have specific provisions that allow for the use or further open the door to the use of alternative cementitious materials other than Portland cement. And they shall be permitted if approved by the licensed design professional, that's us, and the building official. So sometimes getting the building official approval is can be more difficult than other times, but this puts it in writing that is encouraged in the uses of concrete. Okay, so alternative cementitious materials are now explicitly permitted in the code. In addition, recycled aggregates are also explicitly permitted in the code. There are a couple of caveats and warnings about recycled aggregates. Perhaps to me the most important is that if you establish a testing program on a project where you're using recycled aggregates, there has to be a testing program that is ongoing throughout the project. And why is this? With recycled aggregates, the sources can be variable. If you're using crushed recycled concrete, some might come from a highway demolition, some might come from a building demolition, and the aggregate may evolve in its properties depending on where it comes from and where you get it from the aggregate storage. So you need to maintain the quality control and review of the recycled aggregate use throughout the duration of the project. Okay, so that's what's in the code now. Now, what are we doing towards ACI 31825? At the beginning of the code cycle, which started in 2019, essentially, the decision was made to create a subcommittee, we called it N, on sustainability. And this is chaired by Shana Kelly, who is a structural engineer and an expert in sustainability initiatives for all materials, but especially concrete. So we're very glad to have Shana doing that. That subcommittee has 12 members. It comprises 6 task groups. It's kind of as subcommittees go, it's one of the smaller ones, but that was intentional as a way to make sure that it can move quickly through a process that incorporates new material into the code. Now, what is this subcommittee doing? I mentioned earlier, it's maybe a little puzzling why we should have sustainability provisions in the structural building code. In fact, what they are writing is an appendix to the building code. This is material that goes at the end of the code. We're calling it Appendix N for now. It'll probably have a different letter when it's actually published. The idea is to have provisions available in case a project or an owner requires some considerations of sustainability, which is becoming more and more common, that those provisions can be consulted and used for evaluating the sustainability of a particular concrete mixture. Okay, so the idea is very important here. We are not specifying what carbon limits should be in particular concrete mixtures. That's a highly localized, meaning locality dependent number. Some areas of the US and worldwide are able to produce, let's call it, more sustainable concretes than others, just based on the materials that are available and a lot of other factors having to do with availability and production. So I'm talking about ACI 318, want to leave the specification of carbon limits in mixtures to local governments and local jurisdictions. All this appendix does is say, if you have to evaluate the environmental impact of a concrete mixture, this is how ACI believes it should be done. The other thing that this appendix describes is, if you need to evaluate the life cycle analysis or life cycle assessment of the total carbon contribution of a project that involves concrete, this is how ACI believes that life cycle analysis should be done. So it's merely providing tools to do the analysis in a standardized and what ACI believes is the best way to do that analysis. Again, it's not specifying environmental design practices or carbon limits. It's just providing the information that architects, engineers, and owners may need to properly evaluate a project. So as I mentioned, we have 6 task groups. These are working on actually writing the appendix, and some are also looking back at existing provisions that I mentioned earlier for alternative cements and recycled aggregates, and making sure those are coordinated well with this new appendix and with Subcommittee A, which has jurisdiction over some of these provisions as well. Sub N, this is just a rough outline of the appendix. There's a scope section, concrete mixture, sustainability measurement metrics. So these are how to evaluate the sustainability of a mixture. If you're doing a life cycle analysis of a project, that's the measurement of the overall sustainable impacts. This describes how ACI believes it should be done. And then we do have some discussion in this appendix about resiliency, because as I mentioned at the beginning of this talk, resiliency is one aspect of sustainability. So that's an overview of what we're doing at ACI. Here's some lists of resources if this is particularly of interest to you. This is not a complete list, it's just a general idea, and it's evolving. Every month there are new publications and resources available from ACI on sustainability. So I'll stop there and I'll turn it back to our moderator. That's what I have to say. We have a vote on Appendix N tomorrow in the main Code Committee meeting, so that'll be an important time. But I'm looking forward to further advancing ACI's involvement in sustainable concrete design.
We probably have a couple minutes for questions.
Yes.
If you have questions, if you can step to the microphone, that'd be awesome.
So, Andy, a few weeks ago we had the opportunity to have Lindsay McLeese, who's a principal at Farrell Althusser in San Francisco, visit us at NC State, and she's a Friedman Fellow through EERI. And one of the things she works on is very much this topic. And she cited some interesting things that many of us were not aware of. So I wanted to share and see if you all have thought of or considered any of these issues. And her point was that if you were to do, let's say, replacement of cement in concrete up to what allowable levels, and she used an example of 50% fly ash or something like this. And she said that makes an impact. She said, no doubt. But from her designs and things that she's worked with, she felt that the biggest impact that could be made was in terms of structural engineering, was in reduction of foundations or foundation sizes. And she took it one step further to say that she will press her geotechs to get more accurate and better information to allow for more accurate design of structural foundations, which in turn she could show would have an immense impact on carbon and energy. So I'm seeing a lot of things on materials which are good,
Yeah.
but is there anything going on in terms of things that a structural engineer can specifically do interacting with others in the community beyond just ACI?
That is a very good observation. Thank you for raising that. That goes along with reducing the total volume of concrete used. And that, yes, changing the foundation sizes to make them use less concrete is a huge impact. It's one we don't actually see because they're underground. But thank you for raising that. I would have to think about what specific initiatives are ongoing to reduce concrete volume or, as you mentioned, interaction with other disciplines to coordinate that. I can't think of any at the moment, but I appreciate you bringing that up because that's definitely, we sort of, as engineers, we put our heads together and think, and we don't always think outside of our profession. So, but I can't give you any specific examples right now, but thank you.